Section 4.4. Three things here. It's a pretty quick, short little lesson. So, first word, congruent figures. Two figures are congruent if and only if there is a rigid motion that maps one onto the other. So, for example, I don't know, here's a triangle, and there's some sort of rotation that takes it to this triangle. Maybe it's a rotation of 180 degrees. Those two figures could be congruent. They're the exact same shape, exact same size. If you have two congruent figures, you can do some sort of rotation or reflection translation to get from one to the other. The next one, reflections and parallel lines. So here's the thing. If you have some parallel lines like this, the lines are parallel. So we take something maybe like the letter P, and we reflect the P over the first line, K. Take this P, flip it over the line, and it's going to look something like this. It's going to be backwards. Now take that P, the second one, and reflect it again over line M. It'll look more like this. So when they are parallel, the two reflections actually, it's kind of too much work to do two reflections. If we totally ignored that middle P, what would you think this was? A translation, a reflection, or a rotation? Well, from the first P to the last P, did you slide it? Did you flip it? Or did it turn? If you couldn't see the middle picture, it looks to me like it was just slid over to the right. So when parallel, two reflections make one translation. So instead of reflecting and then reflecting again, we could have just slid it over. So some other things to know. If this distance here is, say, 5, maybe 5 inches, the distance from P, from the first P to the second P, is 10. The distance from the, say, pre-image to the last image is twice the distance in the middle. You'll also notice that this line I just drew connecting the P's is perpendicular to the parallel lines. Just some knowledge about it. The most important part is that when they're parallel, the two reflections make one translation, and that the distance between the lines, you double it to get the distance between your first and last shape. Now, the reflections in intersecting lines is a very similar idea, except now they're no longer parallel. You have two lines maybe like this that cross. And we're going to take that P, and we're going to reflect it across this first line. It'll look like this, roughly. Then we're going to take the P and we're going to reflect it again. It'll look about like that. So when the lines intersect, two reflections make one what? If I covered up this middle shape, would you think that we had translated reflected, or rotated? From the first P to the last P, was it slid, flipped, or turned? It's been turned. It was kind of upright, and now it's like down. It was turned. That's a rotation. Your two reflections actually just make a rotation. And similar to this one up here where you took the 5 and you doubled it to get the 10, let's say if this is a 45-degree angle, now keep in mind if this one's 45, so is this one, because they're vertical, then the rotation is a 90-degree rotation. Because 45 times 2 equals 90. Just a couple of little theorems about transformations. So let's look at example 1. If K is parallel to M, K is parallel to M, so these lines are parallel, UV is reflected in line K. So we took UV, we reflected it across line K, and got U prime V prime. Then U prime V prime is reflected again to get U double prime, it's kind of hard to read, U double prime V double prime. So we took this first line, we reflected it and got the second, and then we reflected the second one and got the third. So, first question. A translation maps UV onto which segment? So which one of these is a translation? A translation is sliding the picture. From UV to this one, was it slid? Or from UV to this one, was it slid? Well, notice U is to like the bottom left and V is in the top right. It's this one here. It's U double prime V double prime. Line segment U double prime V double prime because it's pointing the same direction. It's kind of going northeast. This one is going the wrong direction. Now, which lines are perpendicular to U double prime? I like this question because if you are good at, I call it playing school, figuring things out even if you don't actually know the answer, using context clues, which lines, plural, so you should have more than one answer. And by the way, what lines are actually in the picture? There are only two, line L and line M. But in order to actually go through, let's draw line segment U double prime. It's that one right there. Do you see any lines that look perpendicular to that? Line L and line M. Sorry, line K and line M. The next one. Why is V double prime the image of V? Why does V double prime match up with V? The explanation is essentially exactly what I wrote down there. Two reflections across parallel lines is one translation. Technically, it's the reflections in parallel lines theorem. You don't need to know the name. This is what you need to know, is that two reflections make one translation. The last question, the distance between K and M is 5. This distance right here is 5. What is the length of V? V double prime. this length right here. Well, if the distance between the lines is 5, this distance is twice that. 5 times 2 is 10. I'm going to skip the example 3 and 4. I made a new example 3 though, because you will see something like this in your homework. So I drew a picture. Lines that cross at a 41-degree angle. A is reflected across the first line, and then it's reflected across the second line also. Ignore that. That was me doing a bad reflection. So these two reflections make one what? If we ignore the middle one, what happened? It's a rotation. Of how much? How much is it rotated to get from from the first picture to the last picture? The angle between is 41, so you multiply it by 2. Of 82 degrees. Fast little problem, you multiply that number by 2. All right, we're going to go back to example 2. Identify any congruent figures in the coordinate plane and explain. I'm not looking for a really difficult explanation here. If you could tell me if it's a translation, a reflection, or a rotation is all I'm looking for. So do you see any shapes that are the same shape and the same size? I do. Here's one. Here's another. Okay, so let's see here. When you name, you pick a letter and you go around the shape in order. So MPON is congruent to ADCB. And how do you get from one shape to the other? It looks to me like it was slid, which is a translation. All right, what's another one? Ooh, I see a rectangle here and a rectangle here, and they look to be the same size. They're both 2 by 1. So let's see here. EFGH is congruent, and you kind of have some choices here because we could turn the triangle kind of upright. We could kind of swing the triangle down, or we could talk about flipping the triangle over. So I personally am going to talk about maybe swinging it down this way. I'm going to make it a rotation, and I'm going to bring point E down to T. T-U-V-S. There are multiple correct answers here though, so if you want to go in a different order, as long as you are doing alongside E to F first, you're fine. All right, this one. Are these two triangles exactly the same shape and size? Look, this side is 3 long. This side is 3 long. This side is like diagonally across 2. This is diagonally across 2. These are the same shape, same size. So triangle KLJ is congruent. And how did we get from one to the other? It was turned. It's a rotation. KLJ QRP by rotation. And this should be enough to go ahead and do your section 4.4 homework.